So I'm excited about this one. I'm a big fan of Spring. I'm a big fan of AWS, and I'm interested to hear how these teams can go together. So with that, I'll turn it over to Oleg and Matthew.
Matthew, okay. Okay, Oleg.
Hi, everybody. My name's Matt Mekas. I'm from AWS, and I work on the serverless team. You might be able to tell from the T-shirt. Here with Oleg.
Hi, my name is Oleg Zhorkowski. I'm part of the Spring team. I'm a project lead for a Spring Cloud Function and Spring Cloud Stream, and I'm working with Matt and his team in collaborating and bringing Spring technology, specifically Spring Cloud Function, to AWS. And today, we're going to be talking about one of the collaboration, which is how to run traditional Spring MVC applications as AWS Lambda. And Matt is going to help me to, I'm a Spring guy, right? I'll show you how to do it. Matt will show you why you want to do it. Okay, so let's begin.
So it's an important time in Lambda's life. It's a 10-year anniversary of Lambda about now, which is pretty cool. Just 2 years before we created Lambda, our CTO made this bold statement that in the future, the only code you'll write will be business logic. And based on that vision, Lambda was born. Now, a decade on, Lambda's evolved yet quite a lot. There's still a whole bunch of stuff you have to worry about as well as business logic. But I think it's an interesting idea and something that kind of resonates with the Spring model for simplifying code, removing undifferentiated heavy lifting. But another kind of quote that I really like from Andy, then CEO of Amazon Web Services now, of Amazon, saying there's no compression algorithm for experience. Like, this building technology stuff is really, really hard, and you've got to have a few battle scars, a few black eyes, a few bruises to get this stuff right, and there's no real way to shortcut that stuff. So from that kind of vision of we want to just focus on code, the way we think about that AWS is this idea of undifferentiated heavy lifting. And in a serverless world, we try to move as much as possible of this undifferentiated heavy lifting to us. So you can build your business logic and your APIs. And we're looking after physical infrastructure, compute, but also the kind of glue and messaging that sticks all this stuff together. We'll do a very, very 1 second thing on Lambda. Just a quick show of hands. People know what Lambda is, hopefully in this room. Who is running Lambda in production? Couple? Good. So I'm not completely telling you how to suck eggs. Basically, with Lambda, you can provide your code or an image. I don't know if you need to be slightly less close to me.
All right, great. I'm actually trying to listen because it's a bit of but go ahead.
You can provide your code as maybe a jar file or an OCI image. You give it to us, fire an event to it, we'll go and run it, we'll charge you by the millisecond. Don't have to worry about servers. And all of the stuff that we've built to do that, and I'll go into some more detail on how that works, we like to think of as part of a compression algorithm for experience. You don't have to get really, really experienced in how to run that stuff. You can focus on some other areas. So a decade in, about 1 million customers use Lambda. We should get a new public stat around how many invokes we do a month at reInvent in a couple of months. Or somewhere over 10 trillion requests a month go through Lambda. So kind of pretty wild scale. I think that a lot of people who may have used Lambda 10 years ago haven't used it in 2024, might not see how much it's evolved, all the innovation, the number of capabilities, and the kind of gone from building something where you can run sort of very simple functions and scripts to something where you can build really, really rich, complex applications in a really, really powerful way. These applications basically have some code that could be Java, but basically anything that runs in the POSIX space, any of the kind of standard languages. You have events that could be maybe a change in state, like someone's added a row to a database. It could just be an API request, so an HTTP request has come in. Or it might be a change in resource state, like a file has dropped into S3. That goes and executes some code, might go and connect to a database, pull some APIs, and give you a response. If you sort of delve in a level below that, there's 3 mental models we have. There are either synchronous requests, where you'll have an API gets called, it goes off and does some compute. Whilst that compute is being done, we've got a kind of synchronous response. and it's waiting, and then we return a response and we say, okay. You've got kind of asynchronous responses where maybe you're processing data off of a queue. If you're processing that data off of a queue, we'll basically just return okay. We'll process the message. We'll say, okay, we've got the message. We'll return a response. We'll go and do the work. You don't have to wait for it. The kind of most misunderstood one, and what I think is a kind of superpower of Lambda, is this idea of poll-based. So if you've got some sort of pull-based messaging where you're pulling off of a queue or a Kafka stream, in a kind of traditional serverful world, you have to run a poller that's sitting there waiting all the time for a message. Have you got any messages? Have you got any messages? Have you got any messages? That's got to be robust. You've got to scale it. You're going to pay for that 24/7, and you might not get that many messages. We got to.
Yeah. A bit of a.
This one's facing that way, so it's nice.
Okay. Try again with how are we doing on this one?
Better.
Okay, that's great.
I had a hard time hearing it too.
So with our poll-based one, we run a multi-tenanted polling fleet for you. So if you're consuming messages from, say, Kafka or SQS or RabbitMQ, we'll run all of that for you. We'll process those messages, pull them down, just send them in batches to Lambda to go and process. That handles all your fan in, fan out, scale in, scale out. Super, super powerful piece of functionality.
Yeah.
So when you're writing a Lambda function, the traditional way of doing it is you write a piece of code, a handler. That handler takes an object from basically that AWS gives you. So if we're processing REST API from API Gateway, that'll have a specific type signature. If it's a message from an SQS queue, that'll also have a type signature. If it's something from a file change on S3, again, we'll pass you a specific type of file, and then you can run some function because it processes all of that. And so this is where I hand off to Oleg.
Right. So this is very interesting. So can you guys hear me, by the way? Okay, cool. So yeah, this is a sample code how you can write handlers to implement AWS Lambda the standard AWS way. What you're noticing here is, and I don't want to use the word proprietary in a negative term, I just want to say that this is a AWS specific API, and aside from the fact that you have to know this API, AWS has numerous handlers. I mean, I know I can name off my top of my head about 5, 6, but Matt tells me there's more. Okay, so and now you would have to be aware of all of them and how to implement them based on your use case. But if you see something like one of the patterns that you can notice from these handlers, that they are taking request, sending in the response. It's an in and out, input, output type architecture. So in Spring, we have a project which I'm leading called Spring Cloud Function. And what this project was designed for is to give you an ability to implement your functional requirements using standard Java strategy interface called a function, right? And then we provide, within Spring, we provide an array of adapters and enablers to say, oh, you want this function to be a REST endpoint? No problem. We can do that. You don't have to touch your code at all. You want your function to become AWS Lambda? You want it to be invoked via gRPC or RSocket? You want it to make it a message handler? We can do all that without you ever touching the code. So you get a benefit of, or like in the previous example, like you don't have to choose between which type of AWS handler. We will adapt based on the type of deployment you're going to have. So, and I will show you in a second how to do that, right? But this is the benefit of Spring Cloud Function. And of course, you can find numerous talks I have on Spring Cloud Function, so I'm not going to get into all level of details. You can see from the slides some of the key features of Spring Cloud Function and the reason why you want to do that. But let me basically show you an example of how it's going to do, and I'm going to show you the demo. So not right now, you can see that you can implement, wait a second, I think we skipped the demo, so I'm going to, right? Oh, no, sorry, we didn't skip the demo. I apologize. So here's an example of how you would implement, instead of implementing a stream handler, you would implement a function. You provide the appropriate types. We, on the Spring Cloud Function side, will do the proper type conversion. And your function, your standard Java function, all of a sudden became an AWS Lambda. And all you need to do is, how many are using Spring Boot? pretty much all of it. So now you're familiar with the Spring Boot auto configuration. So it's no longer just a jar file. It comes with some functionality. So Spring Boot auto configuration that we provide within Spring Cloud Function will turn this function into, in this particular case, AWS Lambda. So let's see quickly about Spring Cloud Function. So here's just simple, very basic Spring Cloud Function application. Again, I call it Spring Cloud Function application, but it's a Spring Boot application with a single bean of type function. If I try to start it locally, I'm just doing locally right now, right?
Oh, you know, Oleg, you can't see it.
Oh,
I think you might need to come out full screen.
This one.
all right. So you can So you can see the application. So pretty much standard Spring Boot application, no problem. So I'm going to try to start it. Nothing will happen other than it starts and stops, right? Because I can go into depth and say, listen, we can take the function catalog, pull the function out, invoke it, and so on and so forth. But that's not the point. The point is like, I want this function to be exposed via the web, like make it a REST endpoint. How much effort do I have to put into that? Well, about this much. Just add these two dependencies, and I'm going to start the application. And now it's running on port 8080. I go right here, Oleg, Matt, or whatever other name. So now all of a sudden this function became a REST endpoint without you pretty much doing anything by simply providing auto configuration. And now if I wanted to, so right now I'll show you how to expose it via the web locally, but if I wanted to bring this function into AWS and make it AWS Lambda, I can do this as well. And in fact, I already pre-deployed it, but I can show you. So there's a we can go to AWS dashboard. Can you guys see it? So you can see a bunch of different functions being deployed. I will actually redeploy one right in front of you. So, but instead of doing it the manual click and bait way, I will just use a SAM, which is a serverless application model. So SAM build. Takes a few seconds. And then SAM deploy guided. So, it's going to take a little time, but basically what we're going to deploy this function as the same uppercase function into AWS, and with proper dependency specified in the PALM XML file. And at this point of time, I'll also expose it via the web using not the Spring Cloud Function way, but basically delegate it back to the AWS guy because they have this beautiful thing called API Gateway, right? So in fact, you can do it two ways. You can either expose function via URL, that's that feature of AWS, or expose it via API Gateway. The point is that, as Matt pointed out earlier, we're basically trying to collaborate. We're not trying to do things like, yes, we can expose, put it in the container and provide our own functionality to expose via the web. But why when AWS already done it for us, right? So, okay, function is deployed. So now I can just simply do curl well, nothing happened. Actually, null was uppercase, right? So if I do Oleg, then, well, something didn't work, but we're going to skip that. It does work.
Very live, doing a real live demo.
Let me just try it again here. Yeah. No. Why is that? Anyway, we'll worry about it later. It's a minor mishap of a live demo, which sort of expected. Now, going back to the, we're not going to worry about this, but the point is that the functionality was deployed as via API Gateway, and we can access it and so on. So we're done with the demo. So here's the kind of a quick view into mechanics behind it. So we have application code and we have Spring Cloud Function code, which is the layer of adapters that we provide that enables the function to be exposed via, let's say, as AWS Lambda. And then since AWS looking at it now as AWS Lambda, now all the features that AWS provides on top of AWS Lambda can now be applied on this particular function. So think about the fact that you just wrote a Java, you just implemented a standard Java interface, not even a Spring. So in other words, the code that I show you has really nothing to do with Spring other than the fact that it's a Spring Boot application and your function is a bean. The function itself is a Java interface. That's important to understand, right? So you can know nothing about Spring and still implement a function, and that function all of a sudden could be pretty much anything you want, right? So now, back to the sort of the real reason why we are here, which is REST, like a MVC, right? There's a lot of, first of all, from the legacy perspective, like Spring MVC has been around for much longer than Spring Cloud Functions, significantly longer. We're talking 20 years plus longer. Okay, so you can only imagine how many Spring MVC apps are out there, right? Here's an example of one of the implementation of Spring MVC apps. It's a typical REST controller that exposed via unicorn path, right? So again, if you look at not implementation, but the signature, you will realize again, something very similar. It's the request response, input, output, oriented architecture. So there's really the affinity to function, to the functional style of programming. You send a request, you receive the response. So but traditional MVC apps require a web server to be deployed to and run on, right? So can we actually take the web server out and still run the MVC app and treat each REST endpoint as AWS Lambda? And the answer is we can. So here is why we can. Because actually, like previous slide, we actually added in red the adapter logic. And the adapter logic is added through two projects. From AWS, the AWS Serverless Java container, and from Spring Cloud Function, a layer called Spring Cloud Function Serverless Web. So between the collaboration between the two, we can now take Spring MVC app and deploy it as AWS Lambda. So here's an expanded view of that architecture. So we have serverless Java container that integrates with Spring Cloud Function, that integrates with Spring Boot, which sits on top of Spring Framework, right? And that's where the application code kind of runs. So back to the demo part. So now what we have is, we're going to do a different one. So now we have an MVC app. So let me just show you quickly what it looks like. So it's kind of like an emulation of a traditional Spring Pet store. So let's look at some of the codes. So you have your application code, which has a few adapters here. Again, none of this code is related to, we try to make it sort of look like a traditional MVC app, right? So it has some web code. It has your controllers, various different controllers. It has your filter. In this case, it's a cognitive filter, which is AWS specific for security and stuff. And we have our domain objects, pet, error, pet data, and so on and so forth. So again, I'm going to use the SAM to simplify my deployment. SAM build. As you can see, build workshop. Again, you can do it either through SAM or you can do it nvn clean install and go through the dashboard and deploy. There's a direction provided for both of them, right? And I'm going to deploy it. And what we expect is right now that we're going to have the MVC app deployed, and I can still access it as AWS Lambda and receive the data from it. So now, as you can see from the printout, we have a URL. So, since actually it's an error, but it's a good error because it says that since I did not introduce any changes, I can just run it. So I'm going to take this URL that's printed out for me before. I'm going to say curl. And we got all our pets listed here and so on and so forth. For the sake of saving time, I'm not going to hit on the rest of the endpoints. But how many of you notice the time it took for the first request to get processed? It took a little time, right? Because if I do it again, is instantaneous, right? Providing the network latency. So right now, so just quickly to recap, I showed you the Spring Cloud function and kind of take it from the very basics to how to deploy it on AWS, and then took it to one step further and say, okay, well, beyond Spring Cloud function, we have Spring Cloud function web, and that allows you to deploy traditional Spring MVC apps, to AWS Lambda. So now the question is, natural question would be, why would you want to use one over? When would you want to use one over another, right? Because you saw me implementing Spring Cloud function and exposing it as an endpoint. You also saw me taking traditional endpoint and exposing it as a Lambda. So the end result is the same. So why would you want to use one over the other? So first of all, I mentioned the word legacy. So if you already have MVC app, you can actually use it as Lambda without changing any code. If you're in a greenfield development, sure, you can start with Spring Cloud function. But if you're in a greenfield development and you want all the features of Spring MVC, because in Spring Cloud function, it's very primitive in a way of exposing. We can do some basic routing based on the type of request, like post, get, and so on. We can do type conversion. We can do all these Spring Cloud function features. But if you want like validation and all the beautiful features of Spring MVC, we are not going to provide you with them. And we don't want to do that because we don't want to compete with one of our own frameworks, right? So if you want all these features, that you can use Spring MVC as a programming model. If you don't, you can use Spring Cloud function. So there's no like, use this versus that, one better than another one. No, none of them are better than another. It's basically based on what you really want, okay? So, but now back to the latency, cold starts, warm starts, and everything else. So now Matt is going to help you, like we're going to show you a few more demos later on as Matt progresses with his stuff to show you these various different things about performance. But what Matt is going to explain to you right now, the depth, the details behind the scene, because we always talk about things like snap start and native, but from Spring perspective, we just show you how it works, not why it works and what's behind the scenes. So Matt?
Thanks, Oleg. So yeah, Oleg's been showing you like how do you go and take your code and run it on Lambda. And I think that point where he did all those different versions, didn't touch a line of actual application code, is really relevant. But we should also think about why should we be running it on Lambda? What's the point? And what kind of applications is it best suited to? So I suppose the superpower of Lambda is correlating your compute to utilization by the millisecond. So kind of in a traditional on-premises world, you have to get some hardware, you do some demand modeling, think about where your peaks are going to be, you commission that hardware, and if you need more, most of the time you're over-provisioned, and if you have a huge spike of unexpected traffic, you've got a problem and you just start throttling. Virtual machines, the cloud, all these things have helped solve that. And in a kind of VM containers world, life has got a lot easier. We can set up some auto-scaling rules. But there's two places on this graph where Lambda really has a superpower. When we're scaling all the way to zero, we've got no traffic coming to our application, we won't charge you for Lambda at all. If you're running containers, maybe in multiple availability zones, you always need to have some compute there waiting for requests to come in because it takes a long time to scale up new infrastructure. And when we get the spikes, we can scale up incredibly quickly. So you get some unexpected event where something goes viral and you suddenly got a whole pile of traffic coming to your application. In many cases, we'll just automatically scale to meet that. To give you an idea of how much scale we can give on Lambda as of today, we changed the scaling behavior last year at reInvent. It's evolved over the years. Currently, we give you 1,000 VMs every 10 seconds up to your account limit. That account limit is a soft limit. So in 40 seconds with 10 gig Lambda instances with 6 vCPUs each, we can give you 40 terabytes of RAM, 24,000 vCPUs in under a minute. And that's a supercomputer in anybody's book. We can go much bigger on an EKS platform or running loads of big bare metal EC2 instances, but it's going to take you minutes, if not hours, to get to that scale. And you get all of that on a pretty much a standard account without any work at all, without having to set up any auto-scaling rules or policies. So what that means is, if you've got very, very high predictable traffic, you're probably going to get a cost benefit to running it on containers. However, if you've got something that's kind of lower traffic, and I'll talk about what I mean by lower because it's not that low, or it's unpredictable, or it's highly cacheable, or it's spiky, that's a great fit for Lambda. There are a whole bunch of apps that you're never going to run on Lambda. So you've got some monolithic, huge old J2E application, you've got a Windows GUI application, forget about it. It's the wrong platform. However, you're talking about these kind of stateless Spring Boot APIs, streaming projects, data processing. Those are all really, really good fit for Lambda. We do have this kind of cold start behavior. What that means today is very, very different to what it meant before, but you're still going to see some slow requests, maybe a half a second to a second for 1% of your requests. So if you've got a super low latency application where you've got to be single digit response time in the P99, again, probably not the right fit for you, but for most kind of business applications, things that you're using with users, it's probably good enough. And we also think about the rate of change. So if you've got an application that's been running for the last decade and no one's touched it and it's running fine, leave it be. But if you've got something where you're building new features, you're upgrading it, you've got a whole bunch of stuff that maybe you should think about using Lambda. Just to bring some of that to life with some data, we've got an application. When I say low traffic, this is some millions of requests a month, 10 million requests a month. Standard kind of string boot application. It's going to cost you, under $15, maybe $12 to run that on Lambda. The equivalent cost to run that on Fargate is 7 times more expensive, mostly for compute that you're not using, compute that's burning carbon that isn't being used. So on those kind of long tail of applications that are important, they have to run, they have to be available, scalable, but they're not doing incredibly high traffic numbers. Lambda's an amazing choice. Once we get to some sort of genuinely high traffic, instead of being millions of requests a month or millions of requests a day, with big peaks of thousands of transactions a second, we start to see that tipping point change. So here we're now $100 a month more expensive for Lambda than we are for Fargate. At that point, maybe we're thinking, is it worth it? Maybe we're saving the developer time and we'll stick it on Lambda. But if you're getting maybe another order of magnitude, 2 orders of magnitude bigger than that, then you start to get to the point where it's really more effective on containers or VMs or something closer to the metal. That's kind of why we might want to do that. Now we'll go into kind of how it all works. So I'm going to spend a little bit of time diving under the hood into the Lambda architecture so you can see some of the things that we should consider and some of the innovations we've done in the past few years. So if we're flying over in a helicopter 10,000 feet, this is kind of what Lambda looks like. There's some deployment stuff. We've got some routing for requests. And then we go into the kind of interesting bits. So we've got our invoke routing. So events come in, they get routed to some compute that goes and runs them. We have our actual compute fabric, so a whole bunch of servers behind serverless that go and run all these Lambda functions. And then we've got this thing called Lambda Snap Start. Take another quick poll. Who in this room has heard of Lambda Snap Start? 1, 2. I told you about it last year. So that's good. It'll be relatively new. So I'll give you a whistle-stop tour of how Lambda actually works, which I think is kind of fun. Like we say, customers have code. Here, Alice has got some code. She wants that to run in response to an event. We deploy that. That goes off to a configuration service. So all of the kind of JSON that's behind Oleg's function there, how much memory it has, what version of the JVM to use, sits in that configuration service. And then we get an invoke that comes into some sort of front-end service. And that goes and executes it on a worker, on a VM running somewhere. But where does that VM run? So this is where it starts to get kind of interesting. Front-end service has to go and work out where it's running. So it goes to a placement service. That goes, okay, we need a VM, spins up a brand new VM to go and run that function and executes your code. So this is what we call a cold start. An invoke comes into that invoke router. We have to create a VM, so spin up a Firecracker micro VM. We download your code from an S3 bucket along with its configuration, and we start the JVM. That's AWS's responsibility, and we do a whole bunch of work to make that as fast as possible. We then have to start your Spring Boot application. So at that point, we have to start your application. We might have to do a whole bunch of runtime dependency injection. We might need to connect to a database. There's a whole bunch of additional work to do. Additionally, the JVM is now running like the C2 compiler and doing some JIT compilation to get even faster. And that whole thing can take several seconds. With a kind of largish application, you might be 10 plus seconds. On the kind of simple pet application, it was 2 or 3. So when we're thinking about this performance And we quite often use these histograms where we're looking at our latency distribution over time. And what we really, really want is invokes to come in. We want all of our requests to be served as soon as those invokes come in. So ideal scenario, in my version 1 of my invoke router, all of my requests are way over to the right because we're having to spin up all this stuff, do all this initialization for every request that comes in. So over the years, we've been looking at how do we go and make this more efficient. The first way is to introduce what we call a worker manager. This worker manager helps us reuse our compute that we've already got running. So a new request comes in, goes to the worker manager, and it goes, hey, wait a second, I've already got some VMs running. Why don't we go and run your code on one of the existing VMs? And those run really, really fast. They're already initialized. However, if a request comes in, we don't have enough capacity available, we're going to have to do something up. So we're still getting some of these slow executions, but we've moved a bunch of them. In production, typically 95, 99, maybe greater than 99% of them are now on a warm path and running great, 10 milliseconds, 15 milliseconds. We've got this stubborn bit of the tail still running slow. There's a super interesting talk by Mike Danilov, who's one of our senior principal engineers, who dives super deep into all the innovations on the worker manager and how we moved it to cellular architecture and some of the micro performance integrations. And over the years, that's shifted it slightly further to the left. So those cold starts have got faster and faster, but we're still in this kind of seconds. So that's when we started looking at Lambda Snap Start. So how do we get rid of all of this bit that's really the customer responsibility, that's actually your Java application kicking off? And it doesn't
taking care of the rest, wrapping this function with various different adapters and functionalities.
Thanks, Oleg. I think that pretty much sums it up.
Yep.
So I think we're at time. So let's get your feedback.
Awesome.
We're going to hang out here. So
Yeah.
if you
Do we have any questions? We could probably take one or two real quick. Questions? All right. If not, you can come up, talk to them. Thank you, Oleg and Matt.
Thanks, guys. Yeah, we'll be around.
Yeah, we're going to hang out here. So if you have questions, yeah.